Hello everyone, welcome back. This is 11.0 upper wall panels. We're going to go over Panel Builder, PPD. In this exercise, we're going to learn how to engineer our upper wall panels to ensure all the loads are transferred correctly through the building. This is done using the panel bracing calculation. The purpose of this is to calculate the bracing requirements for wall framing so that you know where to insert bracing elements, wind force markers, and ragging resistance markers. Navigate to the Layouts tab and quick navigate to border number 4. Let's run the bracing check to the design code we had set in the border setup by initiating the PCB calculate bracing command. A dialog box will appear and you should see red text indicating that our walls are not strong enough on their own and that we will need to add bracing. Under bracing calculation, you will notice we have a shortage in the X and the Y, measured in kips. These values are calculated by subtracting the wind force and total resistant values. A kip is a US customary unit of force. It equals 1,000 pounds of force and is used primarily by structural engineers to indicate forces where the value represented in pound force is inefficient. Under bracing options, you can see that we have several bracing options that we can enable and or disable as we see fit. We will leave these options unticked for now so that we can manually insert bracing. Click Insert. If you look at the command bar, you can see what bracing has been set as our default type of bracing in between the apostrophes here. Should you want to change the bracing type, hit the Enter button on your keyboard. We can change the brace type by navigating to Panels, Brace Panel, Information, Brace Type. These are our different options. We have K-bracing, single strap, double strap, bridging brace, engineered wood, and wallboard panel. All of these bracing types are described in the handout. Change the brace type to single strap. For stud base or strap angle, set it to 45. And for the material, set it to 250, 43, 50 strap, 10 gauge, 10. Click Save. Now it's time to begin to place bracing on our walls. We're going to start by placing some over here. We'll do some on this wall and down here as well as over here. Once you're done, press Enter, type in PCB. We can see that some of the values have updated, but the text is still red, indicating that our shear walls are still insufficient. Click Insert so we can continue to add bracing. Let's add some bracing around this opening here, as well as this window here. Hit Enter, type in PCB. We can see that all of the text in this dialog box is now black, indicating that our shear walls are structurally sufficient. Click Close. For future steps, we will need to add some borders. Initiate the bset command, and for quantity, set this to 14 and click Update. Quick navigate to border number 4. Initiate the PCB command. In the dialog box under Detailing Options, make sure to tick the checkbox for Create Bracing Plan and Create Hold Down Plan. Do this one at a time. I'm going to do the Create Bracing Plan first. Click Insert. The software will zoom out and ask you to click within a border to place the bracing plan, you're going to want to click inside of border number 7. 1, 2, 3, 4, 5, 6, 7. And let's quick navigate back to border number 4. Type in PCB. And under detailing options, now we're going to do a hold down plan. Let's click insert. And we'll place it in border number 8. And now we have our 2 plans. So going back to border number 7, this is our hold down plan. It's a structural engineering output drawing that shows the locations and specifications of hold down anchors used to resist uplift and overturning forces in a light gauge steel framing system. In border number 8 is our bracing plan. It's one of the key engineering output drawings that shows how lateral loads like wind or seismic forces are resisted by the wall and roof framing system. It's a crucial part of the structural documentation set because it defines where and how the structure maintains stability. Let's quick navigate to border number 4. We're going to initiate the PCB command, and this time we're going to click Report. This is the summary of the bracing report of the current border, our second-story walls. Understanding the bracing report in FrameCAD structure is key to using the software efficiently, effectively, beyond just modeling. A bracing report is a technical output that documents how your building's lateral bracing system performs under wind and seismic loads. It's both a design verification tool and a communication document for engineers, builders, and building officials. Click on the Individual Walls tab. This shows the bracing report for the individual walls of this border. Click on the Brace Distribution tab, which shows the brace distribution report. You can print these reports out for your engineer by clicking the Print All button. For now, we're going to click Cancel. In the detailing options, check the check boxes for Insert Wind Force Marker. Click Insert, and anywhere within border number 4, go ahead and place this wind force marker. Repeat or reissue the PCB command. Navigate to detailing options, and this time check Insert Racking Resistance. Click Insert, and then insert it just below your wind force marker. Before we build our wall panels, we can display our load paths from our upper roof trusses down to our walls. This can be done by initiating the LP load path command. This is purely a visual representation of the load paths and is not required step. It's not a required step of the load transfer process. Loads are only transferred once the reference markers have been placed and the wall engineering has been activated using either the PCB, PPD, or PUA commands. From the upper wall frame plan, run the load path command. The software will zoom out as we need to click inside of the upper roof trusses border, which is 1, 2, 3, 4, 5. The software will now zoom back to the upper wall frame plan and a center line overlay of the trusses over wall frames. If the lines are orange, like our support lines, this indicates that all of the loads are being transferred correctly. If the lines are red, this indicates that no loads have been transferred. Generally, this indicates that our height settings are incorrect. For example, the heights are greater than plus or minus 4 inches from one plan to another. The exception to this rule is if walls are set as structural, in which case the truss or joist lines will always appear red. The loads are still being transferred, but only as evenly distributed loads, not as concentrated loads. Run the load path command again when you're ready to turn off the lines. Type PSET and hit Enter. Under Options, Panel Builder Filter options. Current view only, set this to true. And click the Save button. We're now ready to export our panels from the layout space to a panel detailing space. We will do this by using the Panel Builder command. This command can be accessed via the Structure Walls Panel Builder menu in the menu bar, or via Structure bar and the Panel Builder in the ribbon bar. Alternatively, you can type PPD. With the Panel Builder dialog box open, we can see an unfiltered list of all of our wall panels. As we did in the Truss Builder, we can apply a filter to display panels in the current border view or view panels by zone. Since we have zones set, let's use the zone filter and set it to UWF. From within the panel builder, you can check individual wall fabrication drawings, bill of materials, stud design, and detailed design drawings. To export our wall panels, first make sure that the Fabrication tab is selected. In the bottom left corner of the panel builder, select All and to CAD. Let's take a look at our wall panel detail sheets. Looking at the first detail sheet, we can see a bill of materials at the top of the sheet. At the bottom of the sheet, we can see some familiar information added to the sheet that we set up in the panel and border settings. Here you will also see the quantity required, the panel label, and the engineering status of the studs. Zoom in on the panel drawing and you'll see the orientation of each member in the panel frame. Double-click on the middle wheel button to zoom out to see all of the panels. Type P3D. If you already had your panel 3D command active, then typing in P3D will delete your existing 3D panels. Type P3D one more time, and you'll be taken to your model view, where now we can see that all of our walls on the second floor have been detailed, including our stud base straps. Take a screenshot of this 3D view. Navigate to panel point 1. Make sure you're fully zoomed out to see all of these detailed sheets, and screenshot this as well and submit it for the assignment. If you have any questions, feel free to leave a comment below, and I'll see you all in the next one. Thank you.